This presentation looks at a novel distributed asynchronous information processing architecture as a vehicle to equalize urban and rural economies, using equal access federated services which leverage edge clouds, artificial intelligence, and 5G wireless access. There is a strong tendency for large cities and their surrounding core regions to be the most active, rapidly growing areas of development. Certain economic functions tend to be found only in cities and tend to cluster into certain cities because it is economically efficient. Businesses tend to invest in high-growth areas and often lack incentives to provide required capital to low-growth and less populated areas where both the lack of scales of economy and lack of opportunities to increase efficiency using technology discourage profit-oriented businesses. This tends to rural population migration to urban areas, feeding the vicious cycle of rural population decline. However, recent impact of COVID-19 on urban population has opened new insights into how emerging technologies may radically transform the way we communicate, collaborate, and conduct commerce, transcending the physical proximity requirement to conduct business. While the Internet has demonstrated location transparency and independence in connecting things, people, and businesses, lack of ubiquitous broadband access has prevented the participation of rural economy in exploiting the internet-based economies. Over the last few decades, we've grown beyond the industrial economy to the IT economy and the Internet economy, each of which led to significant inflection points in growth and prosperity. What exactly is the networked economy? It's an emerging type of economic environment arising from the digitization of fast-growing, multilayered, highly interactive, real-time connections among people, devices, and businesses. What's driving the networked economy? Access to businesses through mobile and personal devices, on-demand communication, collaboration, and commerce anytime, in any form, text, voice, image, or video, anywhere, as long as you have broadband access, and the proliferation things that connect to people and businesses to provide visibility and control of the interactions with each other and the environment. A networked economy connects people, things, and businesses without regard to their location. The quality of the network determines the extent to which the trade-off between location and time can be exploited to add value to transactions conducted. Interconnections enable customers to drive choices, select preferences, and make their predispositions known. This interconnectedness fundamentally flips the script. It takes some of the power away from producers of goods and services to drive value and puts it in the hands of consumers in the extended enterprise. Historically, businesses encompass the people, processes, technology, and systems within a company. But a networked economy broadens the scope of everything by connecting disparate, diverse, and plurality of devices, businesses and consumers. However, to realize the efficiency and resiliency at scale, a networked world must be able to provide 1. Equal access to consumers, devices, and businesses with location independence and choice. 2. Distributed autonomous information processing structures to communicate, collaborate, and carry out commercial transactions while assuring both local and global constraints related to privacy, security, ethics and legal limits. 3. Risk monitoring and mitigation processes that span across asynchronous distributed information processing, communication and sharing structures, to provide end-to-end business transaction assurance in the face of outside disruptions such as natural disasters, human errors, and malicious attacks. In essence, business must be reimagined as a federated transaction management across an autonomous distributed entity that allows for local autonomy and global constraint management. In a networked economy, information is the key resource that allows producers and consumers of information to optimize their actions and mitigate risk in real time. The information has to be timely, trustworthy, accurate, and accessible anywhere, anytime. The information processing structures must support both synchronous and asynchronous access for consistent information. One of the key ingredients for creating an information network is the ability to provide a reliable access to information without delay. Independent of location. Independent of the device. Independent of provider. Independent of the consumer. The convergence of wireless 5G technology, fiber-connected clouds and data centers, broadband communications and satellites with emerging federated services architectures allow realizing these requirements. In addition, we believe that broadband satellite-based services combined with wireless 5G network and edge cloud services offer an opportunity to bring equality to rural networked economy and the urban networked economy. There are two ways of 5G access to edge cloud support federated services to both rural and urban clouds. Where there is fiber access, the edge cloud provides high-speed connectivity from the edge cloud to other edge or public or private clouds. Where there is no fiber access, 5G edge CUD is connected to other edge clouds or public or private clouds through a broadband satellite network. Federated edge clouds enable 5G highway with commerce corridors along the way between cities such as Raleigh and Wilmington in North Carolina that would enable drone traffic with 5G to transport goods to rural customers. Integrate AI-based sensors and controllers with rural agriculture to optimize output. Integrate research between universities with video walls. Enable remote learning and create new workforce. Create work-at-home opportunity. Enhance e-commerce and make it available to rural communities with edge cloud and satellite. Enhance real estate marketability. Create new clean industry workforce. Enable telehealth integrating across rural and urban access. Cloud brings unlimited scalability and serverless automation. When edge computing meets required service levels, it is cheaper and faster. However, managing thousands of heterogeneous devices, and hundreds of applications for millions of users at the edge, is problem number one. Dispatching workloads in real time either to the edge, or towards clouds when needed is problem number two. The small video depicts the cloud bottleneck. Just like the genome, the digital workload management blueprint provides encoded knowledge to digital genes, in the form of executable algorithms using digital computing structures, and digital neurons, in the form of executable neural network algorithms, to infuse 4E cognition, embedded, embodied, extended, and inactive. Resulting information processing structures are rendered autopoietic. Autopoiesis is hierarchical intelligence to place workloads where they are optimal, when they are needed and are infrastructure agnostic. Homeostasis is the result of hierarchical intelligence to monitor workloads and their health and reconfigure the workload structure to address fluctuations in non-functional requirement fulfillment. 4E cognition enables end-to-end workload visibility, mobility, and control with cognizing agents in real time to optimize their availability, performance, security and governance. The new information processing structure provides self-managing IaaS, PXE boot, network discovery, OS, network and storage provisioning automation. Self-managing POS with containers, Kubernetes, and pod network provisioning automation with L3. L3 networking with no VM tax, no legacy VM network and L2 overlays. Application stack provisioning, monitoring and reconfiguration without reboot. Tower remote access through fiber access from internet/intranet. Remote visibility and control of IaaS, POS, and application networks independently based on policies. Edge security and federated workload mobility with no shared storage.